Hello everyone, welcome to another episode. Our today's topic is binary search. So first we will understand what binary search is using a visual example, and then we will implement a binary search function in PHP. Let's first take a look at the definition. So the definition says binary search is a searching algorithm used in a sorted array. I'm going to highlight the sorted word because that's very important. By repeatedly dividing the search interval in half. So what this means is every iteration, it removes half of the elements from the array so that the time it spends finding an element becomes half of that on every iteration. So if you have, for example, 10 items, on the first iteration, it will eliminate 5 of them, and then 3, and then 1, and then you will have the element. We will look at that as a visual example. So let's say we have 10 elements, and let's say we want to find the number 7. We will first split the array or the elements into two halves and then take the middle element. So in this case, it's going to be 5. And then we will check if the number 7 is greater than or less than 5. If it's less than, then we will discard the right half and only look at left half. But in this case, since it's greater than 5, we will discard the left half and only look at the right half. So the process is going to continue. So we have completely eliminated the first half of the array. So we're going to continue the process with the remaining items, and we will split it into half and look at the number 8. If 7 is greater than 8, then we will look at the right half. If it's less than 8, then we will look at the left half. So in this case, 7 is less than 8, so we will discard the right half completely and only look at the left half. We will continue the process until we find 7. So we will take a look at 6. 7 is greater than 6, then we will eliminate 6. So now we only have 7, and we found that the number 7 is at the index 6, and our function basically can return this information. So this was an example of how the binary search works in theory, but let's dive into code and see how we can implement such algorithm using PHP. So I have a project set up here. It's just one file, and I have a function here called binary search. It takes two arguments. The first argument is the item that we are looking for, and the second argument is a list of sorted numbers. So it's going to be an array, but the numbers are going to be sorted. Binary search, remember the highlighted sorted word that I showed you in the definition? Binary search can only work with sorted numbers. It cannot work with numbers that are not sorted because it won't be able to detect where the number can be positioned in that list. So, and here at the bottom, I have a numbers array. It's sorted, so you see every number, if you go up, every number is greater than the number previous to it. So, and I'm just calling that binary search function, and I'm looking for 560, which doesn't exist here, so I'm going to just replace that with, let's say, 22. Okay, so when we run our function, it will var dump whatever our function returns. So by default, it's returning -1, which is going to indicate that the element doesn't exist in the list. So let's start implementing it. First, we will check if the list is empty. If it's empty, then we don't need to check it. We can just say that it doesn't exist. So we'll just return -1 from here. And then we will have two variables. I'm going to explain them what they are. Lowest index, I'm going to set it to 0, and highest index is going to be the size of our list, and I'm gonna -1 that, so it's going to be the last element of our array. So this is the highest index that we will look in, and this is the lowest index that we will start looking from. And I'm gonna add a while loop here, and I'll say loop until the lowest index is less than or equal to the highest index. Okay, and then we will remember that we were taking the middle element, so we will need to know what the middle element is in our list. So I'm gonna add a variable, I'm gonna call it middle index, and it will be the lowest index plus the highest index, and then divide that by 2. And I'm gonna get the middle, this is the index, right? So I'm gonna get the actual value or number that is at that index. So I'm gonna say middle item is equal to our list and then the middle index. We are taking the element at the middle index. So I'm gonna check if the middle item is equal to what we are looking for, the item, then we'll just return the middle index, because that's the element that we are looking for and we found it. And if it's not, then we will check if the item that we are looking for is less than the middle item. Then we will update our highest index and we will set the value to our middle index and we'll -1 from it. And then we will check if the item is greater than the middle item, then we'll say lowest index is equal to our middle index plus 1. This is the whole implementation, and this is going to continue once we are updating, once we update the highest and lowest index. Basically the pointers are shifting to the other half where we need to look at, and it's going to continue looking at and shrinking the list down until we found the element, and we will find the element in this check. If we find it, then we are going to return the index. If we don't, then it will eventually, the lowest index will be greater than the highest index, and then we will just return -1 here. Okay, so I'm gonna just run this file and see. So the number 22 that we are looking for is at the 7th index, and if everything went fine, we should see 7 returned from our function. So I'm gonna open up my item and then say PHP binary search.php, and we have the index. Let's try it to the different number. On the second index we have, or on the first index actually, we have 5. So I'm gonna say we are looking for 5. Let's rerun. Okay, we have the first index. Let's take the last number. This is, I think, the 10th index or 9th index. It's the 10th element, but the index is going to be 9 for this. So let's, yeah, we got it. So one thing that I want to mention about binary search, you might not find it efficient for smaller data sets. Like in our case, we have only 10 elements in this array. It might not be that useful, but when you have data sets that are in millions, the efficiency is way better than a linear search algorithm. So I have a function here. I'm gonna just copy and paste it here. I have a function that can generate a random array of any length for us, so we will generate a million numbers and then check how many steps it takes the binary search to look for an element. Okay, so what I'm going to do is I'm gonna just print a full stop here so that we know how many steps it took the function to find that number. And then I'm gonna comment this line and say numbers is equal to generate random sorted array, and I'll say 1 million for now, and see how many steps it takes to find a number. And the number we want to look for is, suppose I'm going to put something random here, and I'm gonna run the function again. So it was not that many steps to find a number in a million elements. It was the 13th index. So let's increase this a little bit, so make it 2 million. So you see the number of steps from 1 million to 2 million is, compared to a linear algorithm, is nothing. So we basically doubled the number of elements, but it didn't take that long to find that number. Now let's bump it to 3 million, so we are tripling the number of elements, but you will see the efficiency is still very similar to million items. So that's basically what binary search is in a nutshell, and I hope you learned something new, and thank you so much for watching. Make sure to subscribe to this channel, and if you have any questions, do let me know in the comments below. I will see you in another video.